Hello.
We're going to talk about anything we want.
Okay, so hello.
Okay.
Do you still remember this Pythagorean numbers? Do you still remember? I give you a hint. Right triangle.
Yeah, it's all in the lemon times table in the power.
No.
That's
If
a
this is
triangle.
3, that's 4. And how big is this? How long is this?
2.
5, yeah. Why is that? Because that's 3 square plus 4 square equals 5 square. Yeah? This is called Pythagorean number.
To find the right angle.
Right. So 5 is the Pythagorean. Okay, so today we talk about Pythagorean triplets.
Triplets.
So what does it mean is that if I give you a number like 1, 3, 1, 5, 7, 4, you need to tell me if they are Pythagorean triplets in this array
What
of
does
numbers.
that mean? Mean 3 times.
It means that I can find 3 numbers which satisfy a squared plus b squared equals c squared.
3, 4, 5. Yes.
Exactly. So how do you approach this problem? If there are n numbers, how do you approach this? Do you understand? How do you approach it? So our target is that you're given a list of numbers, and then you try to find out if they are triplets. 3 numbers, yeah? A, B, C. Let's satisfy that a squared plus b squared equals c squared. This is called Pythagorean triplets. Yeah? It's like A and B are the sides of the right triangle, and the C is the largest side. Yeah? Do you get it? Yeah, see the slope. So the slope. Okay. So you know in the right triangle, A plus B bigger than C. Yeah. Do you get it? You know why? Do you know why?
B equals
Bigger than C. Do you know why? Look, this is the
4 and 3 is bigger than
5.
already.
Yeah. You know why? Look at this. This is a line. Yeah, between 2 points. Yes. Given 2 points, the shortest distance is a straight line, right? Yeah? Is this the shortest distance? Alright? Yes? Okay, so look, this is the shortest distance. So this plus this must be bigger than that, right? Because you go to
This
this
is
and
bigger than this, and this is bigger than that.
yeah, I know, but I'm talking about A plus B equals bigger than C, okay? Yeah? Okay? Please. So now, coming back to the question.
So now,
Coming back to the question that given a list of numbers, sit down please.
Yeah.
And then how do you find out if there are these 3 numbers that satisfy that? Any idea? Any source? Any source? Just any
not
source.
using the projector.
No, yeah, not necessary. Maybe tomorrow, okay?
Oh,
Any source, just random source, without coding. Just give me how would you approach? How would you ask computer to do
All
this?
would you do? Just go one way. 3, 4, 5. Choose the first one,
Yeah.
any random one, and
Why you random one? Choose the first number. Yeah, that's good. Choose the first number and
just put it in the triangle. And
you need to choose the second number.
Yeah, so it must go up. So you just go one by one. So this is 9, and then add 1 equals 10, but 10 is not a square, so you go to the next one. 25 add 3. 25 add 9. So that's 34, but 34 is not a square. So you go to the next one.
So you're brute forcing, yeah? You're searching every 3 numbers.
Yeah. Yes.
Okay, so one way is that, yeah, you can certainly do it. You pick the first number, yeah? And then you pick the second number, yeah? And then you try the third number if it's equal, right? If it's so you can simply do this. Look. Alright, look. For I in range. Suppose n is the length of numbers, yeah? Am I right? Range lambs, yeah? Range n, okay? Am I right? Eric. Now we determine the first number, yeah? Look, now we can determine the second number, j, in
Yay.
range. We only need to try up to I, yeah? Yes? And the third number, right?
Yes.
Third number to j, right?
Yeah.
And then we just need to check if lambs I square plus nums j square equals nums k square, right?
Look right in.
Yeah, we just check. Look, Eric, can you listen to me, okay? Don't just walk around and around, okay? My headache, okay? So you try the first number, you try the second number, and then you try the third number, which they are not equal. And then I can say nums I square plus nums j square equals nums k square, and
So
then
many columns.
and then return what? We found it.
K. Nums. Q.
Otherwise, return false.
False.
Here, outside you return false. Yes.
Yeah.
If the n is the number of carry in the numbers, n is the number of numbers in the array. What's the complexity? That would be interesting. Something we haven't seen for a while. Let's n. Let's another n. Let's another n.
No, n times n. No.
N times n, and then here's one more n. What's that?
N times n add n.
Why n? They are all three n together. So what's that?
N add n add n. No, n times 3.
Times 3? Cubic 3. Come on. To the power of 3. N times n times n. Yeah. Because look, the first one you need to loop iterate n times. Yeah.
Yeah.
That's
I should
another
have
loop.
got that.
Look, that's another loop inside that, and that's another loop inside that. This is very slow, right? It's very slow. Complexity is high. So can we do better? Can we do better? How about look? I give you another hint. How about look? We just interested in first two numbers, and then we can find out if the I square plus j square, the first two numbers square, that's something. How about we put this something c square in a notebook, so then we can look it up with constant time. Do you get it? Look, we can do this. We can do this. Look, we can do this. Look, Eric, let's do it. D equals a set. Yeah. Look, a set. Yeah. A notebook. Okay. Let's put it in notebook. Okay. Notebook. Yeah. And then for I in numbers, notebook dot add I times I. Look, Eric, this is magic. I put the numbers square itself, right? Then I just need to check for I in range n. Okay, suppose n is the length of numbers. Okay.
Why I never see define?
That's okay. I can write define later.
Why there's a dot there?
For j in range I, yeah? Look.
Yeah.
If nums I square, okay, square which is times 2, okay? Plus num j square, okay? In what?
Verse. I.
In notebook, because we put the numbers square itself in the notebook, right? If it's in notebook, then return what?
False.
True. And outside is return false.
False.
What's the time complexity?
N.
What's the time complexity, Eric?
N 3. N to the power of 3.
I just remove 1 4, and why is this 3 coming from? How many what's the time complexity? You must get this right. Come on.
Log in.
Don't say log in. Where's the log in? Come on.
I.
Here is n. Here's n. What's the complexity?
N not n. No, n times n.
Yeah, n square. Come on. Do you get it now? You don't make a random guess. Do you get it? Look, this is.
Close.
Look, this is for loop. Yeah. You try n times. Yeah. And then for each n, Eric, for each n you try another n times. So that's up to n square, right? So which one is better?
The O n times n.
This is better, yeah?
Yeah.
Okay.
A square. N
Okay, so-
square.
We have another solution, okay? What's the space complexity for that one? For the notebook one?
Definitely O something. Yeah, definitely O something.
Notebook. We
O.
use a notebook, so it's ON, right?
Yeah, I said then.
Yeah.
Yeah.
Why? Because we use a notebook to.
We don't need that now.
Okay.
We need the capital N.
Yeah. Okay. Now, let's do it. Define. Let's do a function. Okay, nums.
O N.
So now I'm going to sort this number first.
Yeah. Fine.
Nums dot sort reverse equals true. What does it mean? What does this mean?
It means that the nums you sort it.
Yeah, I saw the number in reverse order. So I saw the number in from the largest to the smallest.
Yeah.
Can you stand up, please? Okay, so now if I look,
Duh.
then I saw this number that will become 7, 4, 5, 4, 3, 1. Okay. Suppose this is the number. Yes. Yes. Yes.
Yes.
Now if look for I in range. Again, range n, okay? We're making the first number I choose from 7. I make sure it's 5, 7, 5 this way, okay? N equals length nums. Now, if I make sure the j will be I plus 1, okay? If I check this is the first number. A. If this is A.
This needs a column.
Yeah, look. If this is A, and I start from here, this is B. Okay, and then look, every time I make sure this is A, and then B will be A plus 1, C will from this side. Okay? So I check. If A square equals B square plus C square, if it is, that's great, we find this number, okay? Right? If B square plus C square is smaller than A square, so what should we move? We should move C here or move B here because they're sorted here. Do you get it? I try to explain one more time, okay? This is a bit tricky. Now I make an assumption that A is 7, yeah?
Yeah.
Okay, now B is next to A. C is at the end, right?
Yeah.
So now I check. B square is 25 plus C square is 6. So that's 25 plus 1 is 26. 7 square is 49. 26 is smaller than 49, right? Yes? Yes?
So B.
So should I move here?
C.
C. Because if I move here, that will be smaller, right?
Yeah.
You'll keep smaller, so I move here. Okay, great. C square, 9 plus 25.
9 plus 25.
34 is still
Yeah.
smaller. Then I keep moving until they meet. Yeah, let's see here. 16 plus 25.
16 plus 25.
31.
41. 41, yeah?
Yeah.
It's still not 49, so we can't find the answer. Okay, now we can't find this answer, then we move A here. Okay? And then B will be here, right? Yeah? C will be here at the end, yeah?
Yeah.
B square plus 1 square equals 17. Smaller than 25. What should I move?
C.
Yes, I move here and I check. Okay, then we got the answer. Do you get it? If it's bigger, then we move the B, right? Because when B moving to the right, that will be smaller. B square plus C square will be smaller. Do you see this? This is called two-pointer. Two-pointer algorithm. Why we can do it? Because this is sorted. This is sorted. We're looking for. Remember, we started this a few weeks ago about finding the number, the two sum. Remember, finding those two sum. If we are looking for the number, like if A plus B equals a target, then we can check this. If it's smaller, we move here, move the right pointer. If it's bigger, we move the left pointer. Yeah. Okay. Now I write the program and you tell me. Okay. For I in range I, j equals I plus 1. K equals what?
K
Equals n minus 1. Minus 1 on the right hand side, yeah?
Yeah.
Why? They are not meeting each other.
Why when it's wild?
Why? J smaller than K. Look, Eric. If nums j I, okay, nums I square is equal to nums j square plus num k square. Return what? Return what?
Return
True, yes, return true. We found it, okay? If num, okay, you tell me what's this,
Return
okay?
false.
Not yet. I square is bigger than num
Return false.
j square. Not yet. What did I tell you about this moving pointers thing? You forgot it. K square. If it's bigger, then
B move.
J, okay, J. If it's bigger than that, no, the left side is C is bigger than that, so we need to move the K, right? Right? K what?
K minus 1.
Minus equals 1, okay? Else what?
Else return false.
No, yeah, we need to move the left pointer.
K add
No, that's not K.
J.
J.
Add equal 1.
Okay, so where do you put the return false? Where do you put the return false here?
Over somewhere here.
Oh, where? You write it where? You write it where? Remember, where's for? You need to write it where? Here.
Yeah,
Outside.
that's what I said.
Yeah, return false.
Yeah, that's where I do it.
Really? Without that, to give you the hint, can you do it? Return false. Eh? Okay.
You
Okay.
need to do it like lie down like daddy.
Okay. That's
need
it.
the
Well done.
You need the catapult letter false.
Oh yeah, capital
Let
letter.
me fix that.
Okay, well done. Okay, that's it. Okay, good job. Okay, what's the time complexity? Oh what? This is for n, right?
So
Here is
n.
And here is another n, right?
N. So n times n.
Yeah. How about this? Here, sorting. Remember, we talk about. Wait. Not yet. We talk about the sorting. This one. This is outside, so this complexity should be this one plus this one, yeah? Alright?
Yeah.
Look at it. So can you not make a mess? Here. So this one is O n log n, okay? Yeah? Alright.
Yeah.
Sorting L n log n. So the overall complexity, look, there are two parts. This one is O n log n. And this bit is O n squared. So which one you think is bigger? Is dominating. This is n times n. And this is n times log n. So which one you think is dominating?
N times n.
Yeah, n times n.
Yeah.
The log n is smaller than n, right? Yeah? So this one is dominating. So when we talk about the aggregate complexity, we only pick the most dominating part. We are not saying the complexity is O n log n plus n times n. We only say, okay, this overall complexity is O n squared. Even there's a small bit sorting here is O n log n. We ignore it because this one dominating. Do you get it? This one takes most of the time, and this one can be ignored compared to this. Do you get it? Yeah? So the complexity is this one. What's the space complexity? Are there any notebooks we need to use? Are there any extra space we need to use?
Yeah. No.
Where?
No.
Where?
No.
No. Okay. So that's all what?
1.
Yeah. Well, what? Constant. When I talk about space complexity, you can make a guess it's O1 because most of the time it's O1 if you don't use anything, right? Yeah. Yeah.
Yeah.
Do you get it? Okay. Sorry. Any? It's okay.
Bye.
I'm close your eyes for 3 seconds. 1, 2, 3.
2.
Okay, so what's this 2 bit? Can you feel
J
it?
equals I plus 1. K equals what? N minus 1.
What's your answer?
What?
your answer is what? J equals
I plus 1.
and this is n minus
minus
1.
1, yeah.
And how about you?
That.
Are you agreeing with this
Yeah,
answer?
yeah.
Okay, we're done. We're done.
Yeah.
Good job. Good job for every day. I will when I finish the coding, I will erase some of it and then let you to do it. Okay, and then good job today. Okay, good job today. Okay, you can say bye bye to.
Bye. Can you remember? Bye. Can you remember it? Bye.
Okay, let's